So in this activity, you're given the graph of a parent function, and you're not given a formula for it, right? But it's this blue curve right here, and we're told it's the graph of y equals r of x, right? And then what you're asked to do is sketch how the graphs of g of x equals r of x quantity plus 2, r of the quantity x plus 1, and r of the quantity x plus 1 quantity plus 2, how those graphs are related to the original. So in the first case, r of x plus 2, how is that graph related to the original when the plus 2 is on the outside of the function like this? How would you describe what happens there?
Shifted up on the y-axis 2.
The graph is shifted up in the y direction by 2 units, exactly. So we've just taken the original graph and we've nudged it upwards at every point by 2 units. So all the points on my new graph are 2 units higher in the y direction compared to the original. So what, for example, would be the coordinates of this point right here? Negative 2, 1, exactly. Negative 2, 1. All right, so we've just taken that negative 1 and we've added 2 to it. And that's where we got the coordinates of that new point right there. Okay, great. So first thing we notice is that this is a shift upwards by 2. I'll kind of keep score here. Up 2. Okay. Then what happens with r of the quantity x plus 1? Which direction was that shifted? This is the red graph that's up on the board.
Shifts horizontally by 4.
It shifts horizontally by 1. Horizontally in which direction? Left or right? Yeah. Here it shifts to the left by 1. So what is it that tells you in this notation that we're shifting to the left instead of the right? How do you tell the difference? That's the bizarro world I was kind of talking about, right? When you're operating directly on the x, you're doing something horizontal, it's counterintuitive, right? Adding 1, which we tend to think of as moving to the right on the number line, right, actually has the effect of moving the graph to the left on the number line. So addition of a positive number replacing x by x plus 1 moves us to the left. So what would be the coordinates of this point right here?
Negative 3.
Negative 1, exactly. We've just taken that x value and we've moved it, we've decreased it by 1. Negative 3, negative 1. Yep. Okay, cool. So then what happens if I try to do both of these things? Right? The function r of x plus 1, quantity plus 2. What happens? That's the green curve that's up here. How would you describe the transformation that happens there from the original?
Shifted it vertically 2 and then horizontally left by 1.
Yeah, exactly. We've done both. Up 2 and left 1. Up 2 and left 1. Right. So here's a question. Did it matter that we decided to go up 2 and then left 1? So if I went from the blue curve to the purple curve and then shifted that to the left to get the green curve, compared to if I had done it the other way, if I had gone left first by 1 and then up by 2, do I get the same answer? Both of those, I get the same curve. If I do up 2 then left 1 versus left 1 and then up 2.
In this case, you would have done.
In this case, it looks like we get the same thing, right? So what we can say is that shifts, all shifts, can be done in any order that you want to without affecting the final result. Shifts can be done in any order. What we would say in mathematics is that all shift operations are commutative, right? If I do one shift and then another shift, it's the same as if I did the second shift first and the first shift second. I can reverse the order in which my shifts happen and have a different process of getting me from my starting point to my ending graph. But the result, the final answer of the shifted graph is going to be the same. Shift can be done in any order. They're commutative. That same thing will be true with stretches as well. If all I'm doing is stretching horizontally and vertically and reflecting horizontally and vertically, all of those also can be done in any order with respect to one another. So just sort of keep that in mind as we go forward to our next activity, which is going to be a stretching activity as well.